Good afternoon, ladies and gentlemen. Welcome to the session on protecting the network. Although if you were here at the plenary session this morning with Bob Coles, you have to wonder why you bother, because according to Bob, everything on the internet is insecure. We've got three speakers in this session. The first one is going to be looking at the core and how we protect the core of the network. Then we're going to have somebody from PSNC effectively giving us a case study on what they do with their incident handling. And then we're going to have somebody from the Géant 2 project that's going to be looking at the role of security NRENs. So I'd like to start off by welcoming Michael Beringer from Cisco. He also, in his past, used to work for Dante, so he certainly knows the community well. And he's going to talk to us about pervasive core security. Michael.
Thanks, Shirley. Welcome. Thanks for joining this session. My name is Michael Beringer. I work as a distinguished engineer working with service providers mostly to secure core networks and to work on the current internet security issues as far as service providers are concerned. And security used to be something much more of an enterprise nature. It is becoming a lot of a service provider issue these days with denial of service attacks and similar things. My paper is titled Pervasive Core Security. If you have looked for it on the web page, I'm going to upload it later today, so I have actually written a paper where I have this text of this session on as well. The basic line of my presentation is a relatively simple one. As Shirley pointed out, I used to work for Dante. In those days, and still up to today in many networks, the security of a service provider core network was defined by securing each single router. And maybe, if you are lucky, the routing protocols between them. But security was pretty much defined as security of a device. Now, if you did a trace route across the network, you could figure out IP addresses of routers, and you could try telnetting to them. And if this telnet session on this particular router was not well protected, guess what you were on? So each router was secured individually on its own, and this is fine in principle as long as everything works according to plan. The problem with security is that if everything ever worked according to plan, we wouldn't need it, right? So the problem is there are always some exceptions in how to handle them. So, and this is the topic of the presentation in one slide. I think this is changing now to a different model. And why is that the case? Because if you secure each router individually, you do have a potential issue. So, in theory, you can take a router and secure it well. And hey, we have been doing that for years. So yes, obviously, this is an approach that works. So you can take every single router, you can secure it with shutting off unused ports, with disabling servers that you don't need on the router, with using strong authorization schemes, AAA, and what have you. Lots of mechanisms that you can deploy, and with this, you can secure a router. So I'm not disputing that. The point, though, is, in practice, there are two issues. First of all, operational issues, and that includes, for example, somebody misconfiguring a router, forgetting this access control list, not putting a strong password on, just operator mistakes, basically. And the second problem in practice are implementation issues. And even though I'm from Cisco, I will say very clearly and loudly here, yes, implementation problems, i.e. bugs, do exist. And of course, all of you who have ever written code know that it is pretty hard to write code that is bug-free, i.e. pretty impossible when you get to a certain size. So yes, also routers run software, also routers have potentially bugs, and some of them may have an impact in security. So those two issues can actually make a difference in the security of the overall network. And then in practice, you have a third problem. What if now you have actually secured this router very well, but you get a packet flood which is using TCP port 23, the telnet port, and at the same time you want to come in on that interface with your regular telnet, i.e. DOS attacks. That is also an issue that has changed life quite dramatically over the last few years, I would say. So what I see happening now, talking to many service providers across Europe, is that many service providers are starting to put something additional in place and do not rely on just the security of the device itself. And this is the new approach I want to talk to you today about. It is essentially a multi-layer approach, something that in enterprise networks has been around for a long time by putting firewalls and additional, what we call defense in depth, additional mechanism to secure the path into the network. So the new world, as we see it, looks similar to the one before. You still secure every route individually, so all of the mechanisms that I mentioned earlier are still applicable, and you would still configure all those security mechanisms, use strong passwords, and so on and so on. But in addition, you build a shield around the entire network, and we call this infrastructure ACLs, access control lists. Access control lists that basically deny packets into the core. So all I'm saying is now, instead of letting this telnet actually get to a core router, we block this off at the edge of the network. And in practice, this ACL means you just deny any packet to the core address space. So it's sort of like the firewall in an enterprise, I would say, except that, of course, in an enterprise network, you don't have transit traffic. So here it's only towards the core address space. Now, the difference to this, in this model now is, even if you made an operational mistake and you forgot to configure AAA correctly, or even if you have forgotten to disable the low UDP ports as servers, or even if you have made any other mistake, well, this telnet packet will not make it to the router, right? And the SNMP packet and all the other packets will not make it to the router either. It is a common security approach, actually, saying, by default, I deny everything, and I only admit what I really need. Now, if you look at this drawing, what do you really need on this? And if this is a service provider network, and if it is designed correctly, what you should need on this is BGP, and that's probably it, right? Depending on setup, maybe you want to let ICMPs through, whatever. So this can change slightly depending on what you want. But the default is deny now, deny packets to the core. And therefore, these operational and implementation issues that we are seeing in the industry do not pose an imminent threat anymore. I am not saying, careful, I am not saying this is the way to change from no security to security. Absolutely not. Under normal circumstances, also traditionally secured core is secure. The problem is, what if an operational mistake, an implementation mistake? So I'm targeting the exception cases. And then, of course, it only protects your attacks from the outside. So if an attacker would be on the inside of the network, you would be out of luck again. So this is not perfect, right? Security is never black and white. But what we have seen already in for example, big vulnerabilities in the internet, big software problems in the internet, if you had a protection layer like that around your core, well, you just had more time to actually think about changing your software to fix your problems, and you can do it in a coordinated way rather than in the emergency upgrade fashion that is quite common still in the internet. So the idea is essentially to isolate the control plane from the outside, and there are various approaches on how to do that. And I will talk about each of those 4 approaches on this slide quickly in a few subsequent slides. The first idea is isolate the IGP. The IGP in a well-designed network is not accessible to the outside, from the outside, I should say. Therefore, it should not be possible in any case to bring IGP packets into the core network. This is one design goal of a service provider network. The IGP should be internal and nobody from the outside should be able to fiddle with it. The second approach I have just outlined a bit more in detail. This is what we call infrastructure access control lists. Do not let packets into your core. Nobody from the outside needs to send packets to your routers. With very, very few exceptions like BGP, like maybe ICMP for some customers. Some exceptions will always apply. That's not the point. The point is the default is now deny. Do not let packets into the core. The third one is controlling the quality of service of transit traffic. This is actually an issue that is not too well understood in the internet. Everybody thinks if you see letters like COS and QoS, everybody thinks, oh, this only applies to me if I provide QoS services, and yes, I do understand what I'm doing. No, shut up, I know what I'm doing. No, there's an additional problem with this. Not only your applications understand QoS and the color of a packet, also routers do. And routers treat packets differently depending on the color of the packet, depending on the quality of service of this packet. Therefore, if I'm a hacker, I would choose to attack with high precedence packets because that has higher priority on your network. Therefore, if you design your network, you have to take this into account and make sure that high precedence packets, precedence 6 and 7, do not get into your core in the first place. Right? Many of those mechanisms are actually complementary. We'll see that in a minute. Of course, if I don't let packets into the core, I don't let packets, never mind the color. So it's a different issue. But you get the idea. These are all concepts that we have to look at. And then, of course, having secured the core this way, you still have this one single open port that's BGP. And no matter what, you need to talk BGP to your peers. So this is not something we can switch off. Since that is something necessary, we just must hammer this with security as hard as we can. There are a lot of security features on BGP, and it can be secured very well if you choose to do so. And another issue that we need to look at also if we design a service provider core network these days is denial of service attacks a few years ago were actually not an issue for provider networks. Well, small issue. Today, they can be an issue for service provider networks, even though the transit traffic is usually not a problem. Service providers are getting more and more attacked themselves. For example, last hop routers in front of a target. So therefore, you have to actually, when designing a core network these days, plan the DOS attack into your network design. Just assume you will be attacked one day and do the according plans. So let me go through those mechanisms one by one and explain in a bit more detail what I mean with them. In my paper, you will be able to read more details and much more background on those things. So, isolation of the IGP. The IGP, as I said earlier, is the interior gateway protocol. Nobody from the outside should be able to mess with that. That is your domain and only your domain. It is not a good design to have services, NTP, web services, whatever you offer as services to your customers, routed via the IGP. This should be routed via BGP to keep very clearly what is accessible from the outside and from the inside. Now, you have to choose an IGP. Of course, most of you will have made this choice already. There is a substantial difference between the IGPs, and there's one big exception here, ISIS. And I know that many people do not like it so much, because if you look at the config, it looks really ugly with those funny addresses, mind you, with v6. You're getting interesting things like that too. So we have a routing protocol that is actually not based on IP. It is using OSI routing. So if you use OSI routing, how do you want to attack that with IP packets? Since almost all of the networks that I know do not do any OSI routing to the exterior, only IP, there is no way to attack an ISIS protocol. This is a very, very strong message if you think about it, and makes the network much more secure by default. Careful, I have been slightly misquoted on this type of recommendation. Of course, the choice of routing protocol does not only depend on security. So more considerations come into that. But from a security point of view, ISIS is a very good protocol. Other IGPs, well, if you have OSPF, that is an IP-based routing protocol. So there I would recommend go back to the infrastructure ACLs. Next slide. Don't let packets into your core. If you don't let packets into your core, you also don't let OSPF packets into your core. Again, you are actually not affected by any potential attack. And that is quite important to shield your network from the outside. And this is, again, what I mean, this overall protection shield around the network. If you run an IGP with your customers, make sure this is not the IGP that you use on the core itself. These are all standard recommendations, and I'm sure you know them. There are also service providers who are starting to use or are already using private address space for the core with the same idea. I use private address space on the core. This address space is not routed on the internet as such. Therefore, I cannot attack it. If my router only has 10 dot something addressing and this is not routed, how shall I send a packet to that? This has some gotchas like default routing. It has quite some nasty looking outputs if you do trace routes. So some people like it, some people don't. I will not take sides here. It is something that is being done partially, and it is worth mentioning here. The infrastructure ACL is for sure the biggest part of this presentation. And if I want you to, if you take anything away from my short presentation here, I would like you to take this part away, because I think this is a fundamental change in the way we have designed networks years ago and how we are starting to design networks these days. And again, I have already mentioned it in principle. The idea is do not let packets into your core. So the first challenge with that is, what is your core? And if you have a small network, you can probably define your core with 5, 6, 7, 10 prefixes. If you have a large service provider network, this might be impossible. Right? So the aggregation of core address space is the first requirement here. You must be able to actually express what that means on this slide here, core address space. I suppose in the national research networks, this should be to a large extent possible, and you should be able to aggregate to a reasonable amount the address space of the core. And then you just say, deny IP any to those core prefixes. And hey presto, you cannot get any IP packet into the core. How can you attack a router? How can you attack a router if you cannot send a packet to it? This is a very, very strong security level. And so people are arguing in favor and against this and say, oh yes, but proper security should be every router is secured on its own, and this is just a shield around it which should not be required. Yes, always keep in mind this is true as long as there is no operational mistake or no implementation error. As long as those premises keep standing, you really do not need that. You need that only for the exceptional case. The question is, will those exceptional cases occur in your network? And the answer is likely yes. Right? So to some extent, to what extent is a different question, but those exceptions will occur. So now with this, you cannot intrude, i.e. penetrate the network and get access on a router. That is impossible. What you still could do is use transit packets to attack the network itself. But using transit traffic to attack a router is really hard, because routers have been optimized for forwarding traffic, of course. So this is not that straightforward as it looks. There are some ways to do nasty things with options and stuff. So there are things that you can do, but it is not that easy as if you can directly address a router. So I've already mentioned a few issues that you may see with that. So first of all, if your core address space is not easily aggregatable, then this access control list on every single ingress point into your network, mind you, is probably going to be very hard to maintain, very cumbersome, very long. Of course, if you have old platforms out there, and many of you do, and this is fully understood, you may have performance issues on some of those hardware platforms. You cannot run long ACLs on all routers, that is for sure. So also this may be a restriction. Another one that people do not like, you cannot actually debug the network from the outside. And depending who you talk to, they say this is either a bug or a feature. So the people that like to debug everybody's network on the internet hate this sort of thing because they can't do their pings anymore. But people that maintain their own network actually do quite like that. Other people cannot see their network. So depends on who you talk to. And of course, this nothing comes for free. This comes at an operational cost. You actually have to do that to implement it. It is a project. This is not something you'll do overnight. I've been working with a number of service providers in implementing this type of solution. This can be half-year projects to actually have this rolled out over the network. It's a big thing. So many networks cannot actually do this right now everywhere. So in I would say actually almost all cases, there have always been exceptions where this router can't do it for this reason, and here you have another issue. My point is, yes, maybe you can't do it everywhere, but if you do it on 80% of ingress points, that's still much better than not doing it anywhere. Transit ACL is another topic that is going away from securing a router network, router by router, and applying something which is pervasive through the network. Transit ACL, what do I mean? An access control list that affects transit traffic. Now, an internet service provider, and it is my firm personal belief, should provide a transparent IP service. That means if I send you a valid IP packet into your network, please, I expect it on the other side out in this exact form. Right? This is what you would generally expect. And I would still claim that this is a desirable approach. However, if you read the NanoGlist, if you read other forums, there are a lot of discussions now on blocking certain ports for security reasons. Port 25 TCP for spamming, or against, I should say, spammers. The Microsoft ports during worm outbreaks are even getting blocked now in transit traffic. Is this good? Probably not. Should we ban it and not do it ever? I don't think so either. I think this is probably a necessary evil we'll have to live with. We will not be able to live without that anymore, but we should at least understand how to do that. If you do things like that, that is typically a temporary nature. Again, the goal should be to have a transparent internet service. Again, routers must actually support that. Access control lists on all the platforms do have issues, and I'm sure many of you are aware of that. Recoloring on the edge. If you are actually not doing something like infrastructure ACLs, where you take the entire network and on every ingress port you say, I stop this packet that wants to get to my router, then you should consider, and maybe you should do this, no, not maybe, you should also do this for transit traffic, recolor and do not let precedents 6 and 7 go through. And now, I am leaning, I can't demonstrate that here because it's too far, but I am leaning far out of the window. There is no RFC that signs what I'm saying right now. This is my personal belief. I think precedent 6 and 7 are routing protocols, and routing protocols are control protocols. Transit traffic, by definition, is not control plane traffic. Therefore, does not deserve, in my opinion, precedent 6 or 7. Nobody is saying it that clearly. Actually, there was also a discussion on Nano a short while ago about exactly this issue. So this is a debatable issue. My point of view, if I was a service provider, and I know that a packet with a high precedence might get in conflict with my routing protocol in certain points in my network, I know what I would take as priority, whether the transparency here in terms of transporting the packet untouched, or whether maintaining my network sane, where I would have my priority. Of course, I would keep my network sane. This is, again, an issue that you cannot do everywhere. It's hard to deploy in some cases. So all of these things have their issues with them. Unfortunately, it's not quite that straightforward. But we need to think about these things, because traffic that attacks a router is looking at traffic also internally, inside the router, is handling traffic differently, whether it is high precedence or not. So therefore, you need to consider those things, even if you have absolutely no QoS service. So this is independent of your QoS model. Overall, we have 3 golden rules for the network. It must be 100% stable, no surprise here. So it must be rock solid, no flaps, no nothing. It must not be attackable. And this is something which, with infrastructure ACLs, for example, you can do to a large extent. If you do not let packets into the core, it is very hard to attack this network. And it must actually sustain a DOS attack across it. Many service providers implicitly understand that. I think it's time to write this down explicitly. We must design our network such that even if on my ingress ports I get completely hammered with minimum packet size of a DOS attack to one single destination, I can do something and my network is still running. Right? Maybe some points not, but the overall network as such must survive this. So I think, looking back some years ago, when you designed a network, you took your traffic matrix, customer A, customer B, bum, 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 bum. You pushed this through a network calculation and you said, this is how my network should look. I say you have to change that. You cannot just assume valid customer traffic. You have to assume this customer is now sending you a huge DOS attack. Now what if you have this gigabit link and you get huge amounts of bandwidth? What if all of those things happen? I'll leave that to you to look at in more detail later. The point is, you will not be able, in no network, on every single point to sustain a DOS attack. In the worst case, something will always fail. But what must never fail are your ingress ports. So in the worst case of all, you must be able to apply on ingress some rate limiters or some ACLs to block this type of traffic. And this is on the left-hand side of the slide. This is my key point here. On the ingress points into your network, you must be able to handle full link with minimum packet size. You must be able to apply ACLs without the box falling over. This is a network design that is, unfortunately, I should say, required these days. Now, if you look at all of this in the context of MPLS, you will actually find that MPLS, and I realize this is, again, a politically very dangerous statement to make, is actually not that bad if you look at it, because the outside is completely separated by architecture from the inside. Because on the inside, you talk labels. On the outside, you talk IP. To the outside, you don't admit labels in. Separation. Very elegant. Now, this comes, of course, at a cost. MPLS is complex. And I don't want to get into political or religious debates here. But this is an interesting security topic for MPLS. And it is a point in favor of MPLS, in my opinion. So, summary. Even today, it is still required to secure every router individually. First of all, even those pervasive core security mechanisms may have failures, right? So also those may not be perfect, and also you have to consider insider attacks. But there are a few new paradigms that are starting to pop up and are getting more and more attention from the service provider community. Isolation of the IGP is one, infrastructure ACL, I would say the main one, and the other points I mentioned. And with that, do we have time for questions?
We do have time for questions.
If there are any questions.
Any questions? Can you wait for the microphone as well before you ask your question?
No questions? I think we also have some Q&A at the end.
We can have Q&A at the end,
so
yes.
If maybe.
Okay, well, thank you very much, Michael, for an interesting talk.
Thank you.
Our next speaker is Thomas, and I'm going to get this wrong, and he's going to tell me off. Nowichin? You can tell me how to pronounce it when you get up here. Thomas is from the Pioneer CERT team, and the Pioneer network, as you've probably realised by now, serves 21 academic metropolitan area networks, which is an awful lot of users that you've got to keep under control. And the Pioneer team have developed their own software that helps collecting and managing incident reports. Now, whilst Thomas is being wired up, I just would like to remind you that the BOF session on ADV is at 6 p.m. tonight and not 6:30. And anyway, I'm going to pass over to Thomas now, who's going to tell me how to pronounce his name.
Well, okay. Hi, everybody. To pronounce my name is Nowocień. Yeah. That's the correct way to pronounce. First of all, what am I going to tell you about today? First, just a short introduction about the Pioneer Net. Then, only a short introduction about our Pioneer CERT team. And finally, about a handling system that is developed by our team. Well, it's not exactly about protecting a network, but about handling incidents in network, which topic is also very important while talking about network protection. Well, Pioneer's Polish breadboard network that is it connects 21 metropolitan area networks and all Poland. 16 of them are connected with its own fibers with a speed of 10 gigabits, and the rest are dedicated channels with a speed 155 and 622 megabits per second. So it gives an access to the internet for most of Polish universities, libraries, and science institutes, and supercomputing centers. And there are also some smaller institutes, companies connected to Pioneer. Well, Pioneer also has its own connection to Jean, to Telia, and some fibers that connect Pioneer to network in Germany, in Czech Republic, and of course there are also connections to other ISPs in Poland. Well, it's obvious that such a big net must face the problems of incidents, of security incidents, and to handle those problems, the Pioneer CERT team was established in Pioneer. First. Well, it was named in 2001 POFI4 CERT. First there were 4, then 5 persons working in CERT, in POFI4 CERT in Poznan, and they have a contact to additional person or persons in each of city that is connected to Pioneer. Sorry. Well, it's written main activity, and it's not main activity, but in fact it is. Okay. Sorry. Good. Higher. Better now. Thank you. I put a main activity. Well, in fact, it's not the only main activity, but it's what I'm going to talk about. So, in this presentation, this is main incident handling. There are also some other activities. For example, security consciousness in Pioneer, especially among administrators. Some security alerts sent to administrators or published at the web page. This year we started with some other activity like training courses. In the field of incident handling, we do almost the same what other CERTs or SARs do. This is listed here. I believe it's nothing special comparing to other CERTs activities. But Well, usually we get a lot of reports reported to us. Well, there are over 1,000 reports a month. Well, in fact, there are not 1,000 incidents, because usually it is that we get reported incidents for many times from many sources. So one incident may be reported for several times. Most of incidents are spam. We also have to face some others. Sorry for the mistake. This slide. We also have to face other incidents, not only spam, of course. Scan viruses, sometimes the interaction to police is also necessary. So to improve the handling of incidents, we decided to build up an incident handling system. The system is it's very useful because it helps to handle incidents. The schema of the system here it's consists of 4 major subsystems. One of them is report collector. It's a very important part that collects reports from reporters from different states and different networks. And then very important is report qualifier that is used to qualify the report and of course verify the report. And after the successful verification and qualification of the report, it's the incident is put into a database and then it's handled by operators. Report collector. This is the part of the system that collects its main role is to collect reports from users, and that's the main role. But it also informs the user about the incident handling status and the report status. It informs user whether the whether the report was successfully verified. Verification is that we check whether the report is a fake, whether the report report the real incidents or it's reported just by mistake. After that, we inform the user about the status of the report. There are 2 channels of reporting. One of them is web form, and one of them is just an email to our CERT. The web form is much more comfortable for us, because every data we get by email we have to put by this web form to the systems once more. So we strongly recommend to report incidents via web form. Here's the example of the form, how to this is in fact the first part of the form where we would like user to define the type of attack that injured him, the exact time of attack, when the attack started, stopped, and so on. And it's also a place to put, for example, log file, and then to commit to the system. Well, I've already said that each report has to be qualified and verified. I've already told what is verification, and now qualification means to put the system, to put the incident for handling for a particular operator of the system. And as I mentioned, a lot of operators distributed. They all pioneer, and then we have to decide who, in fact, is the is to handle the incident. And here's the example of the form of verification. We got first of all we got all sorry, it does not work yet. We got here the type of incident, who reported it, when, and this is most important for us, the address of the system that of the source of attack. After we can also compare to other reports that had targets or sources similar to reported this report. After the report is accepted, we have to qualify who is to in fact to handle. Here is we are to choose the handling authority of the report. There are one of, as I mentioned, 21 mans that is to handle such an incident. And then the handling of this incident starts. Incident handler is a very useful tool because it's distributed. Means not the tool is distributed, means the handling may be distributed. It gives a lot of opportunity, for example, to change the operator of the that handles the incident during the handling process. Each operator will exactly know what points of handling procedures were already done, and what to do next. He got a complete inside view into the history of handling process of any particular incident, and it also helps to supervise incident handling process. And every administrator of a system can check whether the operator does his job correctly. That's the most features of incident handler. Here's the example of the procedures that are in the system, and that helps operators to handle such a incident. Each operator sees incidents, every incident that he is to handle. He may see all data of the incident, all details of the incident. And now we get an example of a handling process. We've got all necessary information about the incident. First of all, it's a unique number of an incident, type, the status of an incident, and who is the operator to handle it. Then we got here the history of incident handling, and the whole story about what point of the procedure were made. And this is a very useful part for operator, because it gives operator exact it gives an operator exact data of any authority that could be involved in an incident. There are also templates of emails, that are very useful for operator to send them to system administrators responsible for offending system. As I mentioned, this system also helps to supervise the process of incident handling. Any supervisor have his own page. He can see incidents, open incidents, and he can see any details of the incident. Here, for example, what did operator do to handle incident? Here are any other extra data about the incident. For example, who attacked, and there is about the reporter names. And then I'm going to give you some useful addresses. First of all, this address of Pioneer network to our network operations center. Then there's address of our CERT team, and where to report. If somebody wanted to test the reporting process from the point of view of the reporter, of course, it is there are two links to the page where to report. First, to go to our web page, then to the section incident reporting, and the second is a direct link to the system. I believe that's all. Thank you. No, any questions?
Any questions for Thomas?
Yeah.
Oh, it's Christoph.
question to your system, how does that relate to other things like RTIR, so kind of incident handling tools?
While the project process of the system, we planned to have the database is constructed in a way to help the interaction between all incidents in ITRR. So, yeah.
Any more questions? Okay, thank you very much for an interesting description of the system.
Thank you.
Thomas. You'll have to get him back, he's got the microphone. Our next speaker is going to talk about the role of securities, the NRENs. It's Christoph Graf from Switch, who's the head of network security there. He might like to start off by telling us all why it took him so long to get to Poznan, but maybe I shouldn't say that. Christoph.
Okay, welcome everybody. Thanks for the introduction. Well, I'm going to talk about the role of security in NRENs, but I start somewhere else. I start with Adam and Eve in paradise. Well, that's sort of the paradise. That's the internet in very, very early days. It was pretty small. All the people on it were good, no bad ones. The bad ones were all outside, but not many people knew that the internet is there. That changed a little bit. The internet grew. Some baddies came in there as well. And lots of people knew about it, but had no chance to get on it. And that changed too. So with the advent of commercial ISPs, it was possible for everybody who wanted to be on the internet to be on the internet. And of course, all the bad guys as well. Organizations tried to protect themselves, and they did it in the way of walls and fortresses. So they set up walls around their organization. They started to do some perimeter security, as we called it later on, and a guardian, or as they were called, firewalls protected the input and output of the organization into the network. But well, growth also inside the organization, so it was not only a small department which was connected to the internet, but in the end it was everybody. So again, some not so good guys came on the internet as well, inside the organization, which is a bit of a problem because the firewall cannot really protect from that. It became much, much worse. So with mobility and roaming, people carry their laptops, they go to conferences, they go back into their organization, so you don't really know where the equipment is. And the perimeter security is, well, quite much failing to protect against such threats. And, well, basically, that's the situation we are. So we are on our own, and lots of bad stuff happens. Now getting to the core of my talk, I would like to present a little bit what I think the characteristics of the NRENs, so the National Research and Education Networks in Europe, is, what the other players are, so trying to map a security landscape which is relevant to the security teams in Research and Education Network. Then I would like to talk a little bit about what we do inside Géant about security and a problem I identified in there, and would like to show what the typical portfolio of a security team might be before going into giving some outlook and discussion of trends. Well, the NREN environment, it does come in many flavors, so there is not just one NREN which is kind of the example for everybody else, but I'm wearing my switch hat, and it might show. So what are the NRENs doing? Most of them, they are designing, straight away also implementing and running services which are not yet commercially available, and that includes network services and also security services. Usually the NRENs, they have a quite high level of technical expertise because the people designing and running the services, they are there in many cases. Since the NRENs are serving the academic world, it is to be expected that they are pretty well networked with them, not only on the technical terms, but also on the layer of people. Usually NRENs, they are not doing research on its own, but they are collaborating with research teams from their constituency or from other constituencies, and hopefully they are learning from that collaboration. Needless to say that the NRENs are pretty well networked among each other. TIRINA, Danti, Géant, they all have their role in here. NRENs usually are pretty open to collaborate and to share information. There is not that much of competition between them because the constituencies usually are pretty well separated. So that's not really a problem. But of course, the collaboration and information sharing has to be perceived beneficial, otherwise you wouldn't do it. Now a slightly complicated picture, the security landscape. Where are the players? With the red circle, that's where I am, that's switch third. So we run this third service for switch or on behalf of our customers. And the relationship to our customers, which are on the layer further down, I think it's a typical customer relationship. So the site security teams, on behalf of their customer, which is the admins and end users, they may call us. We will try to help them. So we get a fairly good idea of what their problems are, and we figure out what we can do to help them. Our peers, we use them for incident coordination. So if stuff popping up which is relevant for other constituencies, we get in contact with them. Usually that's other certs from NRENs, from ISPs, government certs, or certs looking up specific products. We call them vendor cert, be that for commercial products, be that for open source projects alike. On the next layer, which I dubbed it here, focus groups, we work together on the basis of projects. And we also use those networks to do knowledge sharing or to get access to knowledge, and for networking purposes, well, basically one of the reasons why we're here. There are groups in there like TFC cert, Trusted Introducer plays a role here, both directly related to TIRINA. I mentioned some other groups here which are relevant. Sword.ch, for instance, is relevant only for Switzerland, and you probably have other groups which are operating on a national basis as well. Some undisclosed groups where I'm not allowed to give names, otherwise we will be expelled, so I'm not trying to run that risk. And the Géant security activities, they go into the same area. And then we've got FIRST, which is the Forum of Incident Response and Security Teams, which operates on a global scale, which then is slightly further away. For instance, they had an appearance at the World Summit on Information Society, stuff like that, which is more like industry representation, lobbying, things like that. But again, it's quite helpful to get access to knowledge because there are lots of security experts in there, and quite valuable too. Now a look into the security activities of Géant 2. The work packages, there are 5 of them. They were basically put together by people from NRENs like myself. So we talked to each other, figured out what we wanted to do, and we came up with work items 2, 3, and 4. So work item 1 was slightly imposed on us by the project itself, and work item 5 is kind of project management hygiene. That's something which should be there. But 2, 3, and 4 are the ones which we wanted to see in place. Work item 2. So we talked to each other, figuring out what we wanted to do, and came to the conclusion that something is missing, which is a sort of a CERT tool set, which makes life easier for CERTs, which solves their problems. And we wrote down some cornerstones of what that is. I'll go into that later on. In work item 3, we would like to set up an information exchange infrastructure between CCERTs, which makes use of this tool set. And this infrastructure should be reliable, so we have even out-of-band communication in there. It should be secure, so we exchange credentials. It should be efficient, so we talk about how to exchange that information, that it is easily consumable within a CERT team. And the intention is we would like to use it on an operational base, on a daily basis for operational purposes. Work item 4, we say that TFC CERT, which is a task force under the auspices of UKERNA, is quite important. And basically, the security activities of GEON, it's a subset of the people in TFC CERT. And it's not too much to say that TFC CERT is the European CCERT networking platform these days. Now, some observations. Most teams, and those teams who are participating in the security activities of GEON, they are pretty much operationally oriented. So they know what the problems are they have on a daily basis and would like to solve it. And we came up with the idea of creating this tool set. And result-wise, usually they are much more interested in getting results which help them in their daily life than to produce pure research results. It kind of shows the mindset of the people in this group. And now some word about the toolset itself. It's about anomaly detection, to do some network forensics, and other network-related stuff. So it's about figuring out what's happening on the network or what happened on the network, how to figure out which systems were involved, or if you get an incident report, figuring out what actually happened, what network connections did happen before something happened. So you can look into the past. Not too much. Usually it's fully sufficient to be able to look into, let's say, last week or the week before. You don't need much more than that. But that's something the tool should provide, and it does. But there is some bad feeling about that, because the tool set requires network data. The tools we look into right now, they use NetFlow data. But not all teams have access to NetFlow data. So some teams are out. Usually, for instance, government certs do not run a network, so they do not have access to such data. So they will not be served by what we produce in here. But with NRENs, that's something which can happen, but it doesn't happen in all the cases. So now, how to overcome this NetFlow divide? So those who do not have NetFlow, I think my recommendation is try to get it. Because NRENs, they run a network and they run security services, and I think it produces a huge synergy gain when the security team is getting NetFlow data from the network operators, and it helps them a lot in their daily work. So the tool set we have, it's a set of tools based on NetFlow and doing interesting things with that. It helps to analyze hacked systems. It helps to detect anomalies, maybe denial of service attacks, which were a little bit too small to get much attention. You can detect them as well. And usually, that leads to compromised systems, to other stuff you probably want to know about. And very often, you figure out what's going on before operational problems surface. So the security team, so you are not waiting until the operational problems are there, but you spot things and can react to it before that happens. The toolsets, they create information, so you see things going wrong. You can inform your customers about it. And that's something which also fosters trust within your constituency, because you have something to share. You don't have to wait until the customers get to you. And that's something which is quite valuable. And I think we can sum it up very easily. It adds value to the NREN if you do things like that, to your customers, which is very nice. And on top of that, it saves the rest of the world as well. And it's a nice feeling. So this is from a strategy slide of Switch. It shows 4 cornerstones of what we are doing. So we do the regular C-cert stuff every cert is doing, I hope. It's information services, community building, that's the proactive side. And on the reactive side, we operate a security help desk. We offer incident handling and coordination. I think that's the usual stuff. On top of that, we do some critical information infrastructure protection. And that's a hype thing with governments. So what we do there is we are engaged in a project with the government, and basically we sell them the same service we do in the C-cert, but we label it slightly different, so we gain lots of synergy from that. We repackage the cert package, label it critical information infrastructure protection, and a third one is security services, and that's exactly where the toolset is coming into the picture. So we try to do anomaly detection, malware signature sensing, and some sort of internet threat-related consulting. And we give it quite a high weight. That's why you see it on the list of 4 topics. It's there. And last but not least, we run a lab to try out new to figure out what malware we find on the network is doing. And we draw our conclusions. And again, we use the toolset to figure out which other systems are potentially affected by the same thing. And we do network sensor development. And we collaborate with security research teams within our constituency. In work item 5, we have this project management hygiene thingy, which is this advisory panel. And those are the 4 major points which came out in the discussion with this panel. So we think those are pretty important trends which we have to consider in future phases of the GNR2 security activities. One of them is that the critical information infrastructure protection, it is a huge thing with governments, and they have their own notion of what the critical infrastructure is. But nevertheless, for our constituency, the network itself is something like a critical infrastructure on its own right. And this creates new expectations, and maybe we have to produce new services, maybe 7x24, maybe we have to be faster, maybe we have to automate things. But that's something we have to be aware of. There are new requirements coming towards us and new expectations. Another thing is about law enforcement and legal issues. So the laws are increasingly enforced in the virtual world. Long times it was, the physical world was where the law enforcement was active, and the virtual world was kind of a law-free space, but that's definitely no longer the case. The laws are there, they are valid in the network, they are valid in the real world, and now they are getting increasingly enforced. And maybe new regulatory requirements are looming, and maybe in the end something like what we consider the toolset right now might in the end be mandated, so that you have to run it. Because the network, the criticality of the network is increasing. Sorry for that. At the moment, we are running this toolset on our network to find stuff which is going wrong. And the ISPs, they They see what we are doing because we talk to them as well. And they have somewhat mixed feelings about it because they see what's possible and they are afraid that in the end it becomes a requirement to run such services. And we are proud of being able to run them, but we don't know what the future will look like. But we'll see. And the outcome of it is there definitely are educational needs because we have to deal with law enforcement, with those legal issues. It's a new language we have to learn, and we are not really well prepared for that. Another thing, more on the technical side again, is the convergence of voice data and all the gadgets flying around with lots of wireless connections of all types. And all the new threats are hitting a somewhat unaware community. For instance, the voice community, people using the telephone to call someone else are not really prepared to see that denial of service attacks are maybe affecting that one as well. And some new threats like spam over internet telephony, well, it's new for the Europeans, it's not new for the Americans due to the model of services they had. But we'll have to protect the new services. It creates new needs to do some education, and maybe we need new tools, for instance, to look after the voice over IP services. And the last one is kind of adopted grid impact. It has to do with, now on the network we have light path connections across the network, and maybe many of them. And it's a sort of an overlay over the existing network. There is traffic on it which we do not see. So the traffic on it is not really protected with what we are doing with our tool set. And overlay networks, other networks, they tend to become interconnected with the regular IP service. And in a way, it's a high-risk parallel world with pretty high bandwidth interconnects on IP layer. And from the security perspective, we think it has some interesting risks associated with it. And I think that the grid community is in a way underserved with CERT capabilities, and there is lots of potential there for improvement, I think. So the next phases of the security activities in Géant 2, some statements about that. I think it will still be driven by the operational needs of the Géant partner security teams, because those are the ones who are active in JRA 2, so their needs will be considered. And those are network-minded partner security teams. It is not focused on pure research, and it has to do with the people in there. They are pretty eager for operationally relevant results, and it's not pure research, but we are moving in uncharted territory. So the services which we are trying to set up, they are not just commercially off the shelf available. And finally, well, we would like to push the services we have now into operational in a small subset of the partners in Géant 2 to kind of become a commodity for all of them. So we would like to make some statements about Géant 2 partners, like that they should host a security team, that the team is equipped with a minimal set of capabilities, that it is embedded in a coordination infrastructure, and that it is following agreed operational standards. So that's kind of in the future. That's not something which we are working on right now, but something like that we think does make lots of sense. This time it's not me. And the last statement on the security activities, it should be focused on the description of work. That's what we are doing. If other interesting stuff is popping up, we either keep it for the next phases of the security activities, or GFC CERT takes care of that. Because the security activities, it's a subset of it. So that's no problem. But we stay to what we said we are going to do. So I'm back to that slide, and there's a part 2. an image. This is an image taken with a mobile phone, like the one which is interfering with the loudspeaker here. It's from a research lab in Switzerland. I'm not saying which one. And guess what is it? Well, of course, it's an oscilloscope. But it's also a bot, so it's a hacked one. And this is the message we got from the people who we sent a report about a hacked system. Enjoy.
Thank you very much, Christoph. That was a very entertaining talk. Any questions? Or is it too late in the day? Yes. There's one on the left and then one on the right. We've gone to the right first.
It's more a reflection, or I would like to hear your opinion about, at the beginning of your talk there was a diagram with the certs and the different academic certs and focus groups and all the like. I have missed there some forum for making a liaison among the different certs at a national level. Is because it did not fit in the diagram, or is because you don't think it is important?
Well, I mentioned one which is relevant in the context of Switzerland. And I think, yes, every cert should look into what you have on a national level and try to network that bit. And that's what we are doing. And I think it will apply to Spain in pretty much the same way.
Yeah. The point was that it's being considered inside the whole stuff.
Yes.
I did not see it on the. Sorry. So I overlook a little bit the diagram.
Okay.
Christoph, just one question. I mean, I see now that there's really a European sort of coordinated activity on certs. Partners. I mean, GERNT is connected worldwide to other research networks. Are there international cert activities as well? Do you cooperate? And specifically for the interest of Latin America, is there a way that the Latin American certs can cooperate with the Europeans to make sure that, you know, transfer of knowledge is as quick as possible?
Yeah. I think I have to go back to that one. There certainly is, and on the layer, and on the layer of, which one is it? Confused me with my own slides. On that layer here, on incident coordination, of course, we collaborate on with whoever we know is helpful in this context. Definitely yes. On the upper layers, it depends a little bit on what's available. For instance, in the States, well, usually they are quite important to us in many areas. We've got this level here, we haven't got that one, and we've got that one. So there is something missing. So we do not have, in many respects, we don't have a partner which is kind of working in here to collaborate with. And I would pretty much welcome that. And if that happens in Latin America, that would be definitely great.
Any more questions? In fact, any more questions for any of our speakers this afternoon? No? Okay, well, thank you very much, Christoph, and thank you to all the speakers. Can I remind you that buses leave from outside the Congress Centre at 5:45, and there are 2 BOFs taking place this evening if you're interested. And sessions start at 9 o'clock.